Good morning, good afternoon, good evening. Welcome to Hands-on SAP Dev, another episode with me, DJ Q Macro. Welcome everybody. So visas, good morning. Is it? I never know. I don't know whether I even pronounce it correctly. Visas. Let me know how I should pronounce it. Visas. A good old friend of the channel, and welcome to you, Steph. And buongiorno to Chiara. Hi, all from the north of Italy. Hello to you as well. Amazing. So yeah, we're back with another episode. My brain's going like a million miles an hour. I think it's because I'm halfway through my second coffee. I had the first coffee, obviously, you know, when I was awake this morning and doing a bit of prep for this. Good morning to you and welcome everybody. It's a beautiful day here on the Macclesfield Canal. Robert Shields in the house. Oh my goodness me, welcome. The most amazing old friend of mine. I don't know how long we've known each other, but you know, we go back, way back. Welcome, Robert. Amazing to have you. So yeah, we're going to have an hour of me rambling on yet again about functional programming. There's a little bit of SAP Cloud Application Programming Model flavor in there as well. But oh yeah, before I forget, let me just share the link to this week's SAP Developer News, which came out last night, of course, weekly news episode. And yeah, let's get started. So let me switch to let me get rid of that. Let me switch to, in fact, I'll put my head at the bottom for a change. There's a couple of things that since the last episode. Is it since the last episode? 29th of April? When was the last episode? I have no idea. Anyway, 29th of April. Yes, it was this week I wrote this. So I've written a couple of blog posts this week, both sort of related to the topics that we're covering. Let me share this first one. First of all, put that in there. And that really is all about thinking. I was thinking hard about what we were talking about when we were exploring reduce. So rather than go through this blog post, this was only a short one, and Andrew, a good friend of the channel and of the show, commented, which is great. So we love your comments on the blog posts. Good morning, Matthias. Good morning, Matthias in Mescada. So I'm going to sort of have a quick demo. We'll go through what I was talking about here because it's quite interesting. And also, while I'm on the subject of sharing things, yesterday I think I had this in my head for a long time. We have the developer advocates give lead code jams and the service integration code jam. In fact, I'll jump straight there to exercise 4 in the service integration code jam. And it always sort of bothered me. I was super curious. Once we'd imported, if you don't know this code jam, it doesn't really matter. But basically, in the previous exercise 3, we bring in the API business partner OData v2 API definition in EMX, do a CDS import. And then we have a sort of a definition in the serve external directory, okay? But even when we haven't referenced that anywhere, when we start up the CAP server, the CDS model is loaded not only from the usual suspect places. Let me make that a bit bigger. And also, of course, that's loaded because it's referenced in schema.cds. It's sort of imported, as it were. But also, this is loaded. And I'm thinking, well, why is that loaded? Because we have the rules about where the compiler for the server looks by default, the roots. Anyway, I started to dig in and looked at the code behind the scenes. So this is a bit of a longer blog post that you might be interested in because it really sort of goes to town on using the understanding and comfort of function chains and higher order functions, all the stuff that we're starting to learn about in this series helped me understand and read the source code of the CAP server to figure out what was going on, right? So anyway, have a look at that. Let's close that, put that in there. There. So let's go back. We don't need that anymore either. I'm going to keep this one because I'm going to go back to that one shortly. So remember, by the way, ask questions at any time, give me your comments and everything. What I want to cover today is a little bit more on reduce and then move towards function chaining. Now, we did, right at the end, have a glimpse into the beautiful future that is partial application and, you know, sort of by inference as well, function currying. Okay, I don't want to dive into that in this episode. I want to cover sort of, or get to play around with function chaining first, because function chaining sounds really sort of highfalutin, but it's not. It's actually quite simple. So do that first, and then we'll move to partial application and stuff in a later episode. But first, where are we? Here we go. This is where we left off. And one of the things I was saying was last time was if we say here, I think let's just run that, and then also run that, and then if we do nums reduce, we can see, of course, then 1 plus 2 plus 3 plus 4 plus 5 is 15. Now, I was saying that reduce, if we look at the rammed definition of reduce, RB Fernando 99, good morning and welcome to you. Welcome in. If we look at the rammed definition of reduce, we can see that it takes 3 things. We looked at this last time. It takes an iterator function, it takes an initial value, and it then takes this list of things that it's going to iterate over, okay? And we sort of had a stare at this and thinking, where are the 3 parameters? Well, the first parameter is sort of implicit, or sorry, one of them. Let me not do it in a cardinal way or ordinal, I can never remember which way around it is. I'm not going to say the first, but the data parameter is sort of here because, of course, the reduce is a prototypical function on the array object, right? So we have the nums here, right? And then also we have the iterator function add here. But what is missing here, because it's optional, was the initial value. But it doesn't matter in regular Node.js, regular JavaScript reduce, the array.prototype.reduce. What will happen is that it will say, you haven't got an initial value. So what it will do is not as, I didn't quite think this, but I was thinking along the lines of this. It won't sort of say, well, the default value is then 0, because that doesn't, if we were to have, for example, we did this the other day, didn't we? Mult equals, in fact, let's do it this way. Mult like that. If we can still do this, right? Let's run that one, 15. But if we now were to say mult and run that, just bring that in, define that one, and then run that, we'd get 0, because of course an initial value of 0 times anything is going to be 0, so it's going to be 0 the whole way through, right? So having a default value of 0 for the initial value doesn't make any sense. What actually happens, and that's what the first blog post that I shared sort of explains a little bit, is that, is that, I'm just looking at my, how much time we've got, 8:09, okay, very good. Is that what it does instead, it will take the first element of the list and use that as the initial value. Now, a good old friend of mine, and a friend of Robert's as well, on Hachyderm, on Mastodon, pointed out that this sort of is a subtle difference between what reduce is and what fold is. But anyway, we're not going to go into that right now. But anyway, so what we'll do is we'll say, instead of this add thing here, we'll say in fact add verbose. Okay, add verbose equals takes x and a y, and we'll say here console.log, as in we're doing something verbosely here, x plus y, like that, and then return x. In fact, let's make that a bit bigger. There. X plus Y. There. Okay, so let's just do that. And now if we say here add verbose, what happens? We can see what's going on. Now, what can we see? We can see that the initial value for X is the first value of the array. Thank you, Visas. Thank you, Visas. Is the first value of the array, right? If, however, we were to say, give it an explicit value and run that, there's the difference. It starts with the initial value and the first iteration then is with the first value. Does that make sense? If, however, we were to omit, let's go to Rounder. Can we do that? Can we omit things? We can't really omit it. Okay, so let's try it. If we were to say, we've got this max, this is from last week, right? If we were to say reduce get max and omit the initial value, now it's positional, right? So we can't really omit it. But even if we did, and I think we did this, and I said, oh, that's an interesting outcome. I'll explain that another time. Let's do that now. Get max nums, right? We've omitted the initial value, which sort of is supposed to go here. Jithin, good morning to you. Good morning. But what we get is this function definition. Okay. Now, what's going on there is something that we saw briefly right at the end or towards the end of the previous episode. And I want to explain that a little bit now and then sort of park that and sort of start looking at function chaining instead. And then, but that will hopefully give us a bit of an appetite for partial application and currying for next time, right? So we can't sort of properly omit the initial value. However, can you see what's happening here? This is, of course, on the left-hand side here, over here, whatever we type, the last thing is effectively, or everything is evaluated, and the value of the last thing that's evaluated is actually printed on the right-hand side, okay? So if I were to say, for example, let's just get rid of that, and then say 42, of course, it's just going to evaluate that sort of literal constant there. So then reduce get max. Now, what is happening there? What is happening is that, and I'll say this out loud for us to think about, all functions that are supplied in Rounder, so the reduce function here, and all the other functions in the documentation, all these functions here, right? These are automatically curried. Now, I haven't explicitly explained what currying is. I'll try and briefly explain it now, and let me know in the chat whether this makes sense. Please let me know in the chat if this makes sense. And it's only an initial explanation, but we'll go on to look at what currying really is and what the effect of currying is and what it gives us in terms of partial application, or being able to partially apply functions. And this also leads us on to another concept in functional programming, which is point-free coding. I'm going to sort of cover that and make sure we understand that. A function, when curried, what it will do if it expects, let's say we have a function that expects 3 arguments, or three arguments, right? So we've got 3 parameters to expect 3 arguments. So get max, so reduce is like A, B, and C. Move my coffee cup out of the way. In fact, I'm going to put the following in sort of in a comment so we don't get errors on the right hand side to confuse us. Now, if we've got that function there, if that function is curried, it means that we can call it like that, and what we get as a result of calling it, what we get back from the call is not sort of the answer or not what we're expecting the function to do for us. What we get back is another function expecting the next argument. Okay, I'm going to say that again. When we partially apply, as in when we only give a partial number of arguments to the function, what we get back is another function that's still waiting for the final argument or arguments. Okay, why would that even be a thing? We'll dig into that. We'll dig into the whys and the more of the details in another episode. But I want to sort of cover this now to sort of explain where this weirdness is coming from, where we do say, for example, reduce get max there. What we get as a result of that is a function. That function is expecting an argument, or actually, if you could give it two arguments, we could say, let me do this. We could say here, reduce get max 0 nums. Let's call the whole function, right? We get 30, okay? That's fine. We could do that, and we get a function. And then we could supply to that function, so as into the function that is the return value, as it were, of that, we could supply 0 nums. And we get 30. How weird is that? We could even still continue to only partially apply that function and get back a function that's still waiting for the fact. It's like, please just give me the last argument. I'm just waiting for the last argument. Nums 30. So I'm going to leave that there. But before I move on, I also want to point out something really subtle, which is, have you noticed here, and this will be true for all of the Ramda functions in this category, the data that you're working on. Okay, so the data that we're working on here is nums, right? It's the nums array. Is always the last argument expected. And that is a super important aspect to doing currying and partial application right, and to be able to write point-free code that makes sense. Anyway, I'm going to say that and then park it. Is that okay? Let me know in the chat if that's okay. Now, this morning, I went on a bit of a walk this morning. I thought, what am I going to talk about? And there's my notes there, right? I don't really normally write notes. But I wanted to make sure I covered these things here. Okay. Now, what's the next thing? The next thing I want to cover is this idea of chaining. So we've talked about, we know what higher order functions are. They're functions that you pass other functions to as arguments, and or functions that emit other functions, right? Good morning, Andrew, and welcome. We understand also that these functions are sort of composable, as in you build functions from other functions. And that composability, that's one of the key words that we saw on one of the slides initially. That composability is a super important aspect as well. And function chaining is sort of related, at least in my small brain, to composability. If you look at, for example, compose. Here's an example of compose. Classy greeting is also a function definition. There's an arrow function. And also r.toUpper is also a function, okay? And you can build a new function that does something that you want to do by composing, by just joining together one or more or two or more functions. And that becomes then Yell greeting, okay? So of course, classic greeting is just the names, Bond, James Bond, or whatever, right? But then to uppercase, the output of the first one. Anyway, so that's compose. There's another function that's strongly related to compose, which is pipe. Okay, which sort of, think about it going the other way in terms of sort of the needle of data going through the functions. But anyway, I've just noticed up here, we've still got this tab. Would it be okay? Let me know in the chat. Andrew, let me know in the chat. Do you think it's a good idea, before we move away from reduce, to do this, but to do this sort of manually in my sort of REPL environment here? Let's do a REPL clear. Now, there are two statements that I've made at least a few times in the past couple of episodes. One of which is reduce is the function, the mother of all functions, and you can build other functions. You can write other functions in terms of reduce. And I've also talked about the fact that while the word reduce, the English word reduce, sort of has this concept of making smaller, which has meant that folks think of reduce as something that produces maybe a scalar value from a list of things, like for example nums.reduce add verbose. There we go. Let's just run that. There, that gives us 15. In fact, let's just get rid of the add verbose. There, we've reduced this list, this array of numbers, to a single number, right? Thank you, Andrew. We'll do it. Another thing I said, and I think I did one demo, I said that reduce can also be used to build up structures. So let's combine those two thoughts and create our own version of the map command. Now let's just remind ourselves of what map is. So we could say nums.map xx plus 1. That's a ridiculously simple example. So we've got our nums at the top here. Get rid of that. Nums at the top. And this thing here, let's run that. What we're going to get? 2, 3, 4, 5, 6. So map is a function that takes an iterative function and basically produces an array, a list, the same length as the list it reads in. So nums has got 5 values. Map is always going to produce 5 values, an array of 5 values. And but the values themselves are going to be the evaluation of this function on each of the items. So x is 1, x plus 1 is 2. So the first item is 2. You get the idea, right? I'm actually making it more complicated by trying to explain it, right? Or for example, I think the example we had was let's give us the powers, or maybe that was in the in a previous thing where we were doing the object thing. There we go. There, 1, 4, 9, 16, 25. Okay, so that's what map is. So why don't we create our own version of map using reduce? We'll build it with reduce. And I'd mentioned as well the difference. One of the differences between the arrow function expression syntax, as in this fat arrow thing here, a function definition. Here's a lambda function, right? There we go. There's the lambda function. So there's a lambda function. We could have also said, for example, function x return x to the power 2. Let's do it that way, right? There, fine. That's an equivalent syntactical definition of something that will return, x to the power 2. And I'd said that one of the differences between this sort of function keyword definition syntax and the arrow syntax expression is that with the arrow syntax expression, we don't get this concept of this. Now, this in JavaScript is a little bit like self, but it's not quite like self because self is more sort of from the OO world. But this refers to me, as it were. So let's just write it and then explain it. Maybe I should do that. So we'll leave that there, nums.map. So we can say array.prototype. I don't know, my map. I think I've called it our map on this slide, but anyway, my map. In fact, why don't we say here, function return 42, right? That's just the simplest thing that could possibly work. There. Array.prototype.mymap. Oh, sorry, what am I doing? Equals there. And now we can say nums.mymap. Let's run that. And we get 42. Okay, so that's the first step. We've been able to add a prototypical function to the array object so that we can call this new custom function on any array. 123.mymap 42. Okay, let's get rid of that. But now, what do we want to be able to do? In fact, let's undo that. What do we want to be able to do? We want to be able to say that, right? So we want to be able to pass in a function. So my map needs to be a higher order function. We want to pass in a function. So we've got to have a parameter here to receive that function. Let's call it fn. Okay, so now let's just run that there. We still get 42, but we're now allowed to pass in something. Let's start to define what goes in here. And this is where we get to need access to the array instance, the instance of the array, i.e. the nums, i.e. the 1, 2, 3, 4, 5 list. And that's what this is. If I said, I could say here console.log this and then return 90, whatever, return 42. Let's do that again, right? So if I run that now, there. In fact, let's just make sure, let's just show you that this is this. Let's run that, clear the REPL, and then run that. This is 1, 2, 3, 4, 5. Okay. Okay. So we're getting there. All we need to do, let's get rid of the console log, is to return, because don't forget, we need to use the return keyword to return something out of a block. Okay. Return this dot reduce. What do we need for reduce? We need an iterator function and an initial value. Let's do the iterator function in a minute. The initial value, what we need to return is an array, don't we? Okay, so let's start with an empty array. So there, this second parameter is the initial value for the accumulator. So let's now start to define something like that. So our iterator function is this thing here. Now, array concat mdn. There. The concat method of array instances is used to merge two or more arrays. This method does not change the existing array, but instead returns a new array. So the first thing is the last bit here. When we concat, let's do it in Ramda. Can we do it in Ramda? Let's just get rid of that. Concat 1, 2, 3 with 4, 5. There, okay. Now, if I were to say, 4 like that, 4 is not an array. So concat is expecting 2 arrays to concat together, okay? So what we need to do is say a.concat. So we're taking the, in fact, get rid of it. A, which we know initially is going to be this empty array, because it's the initial value here, dot concat, because, so that's the Ramda version of concat, but we could still do, for example, a equals nums of nums dot concat 1, 2, 3. There, okay. So you can sort of start to see the difference between these prototypical functions on the array object and sort of the more neutral functions like concat opened and the function and the arguments there. Does that make sense? So that's the same as concat nums 1, 2, 3. There. Let's get rid of that one there. There. Perfect. Okay. A.concat. But we need to, let's do that, right? Let's just do that for now. What's that? X is declared, but his value is never read. Okay, perfect. Thank you very much. I don't care. Let's just evaluate that, and now evaluate that. So what we're doing is we're iterating over what's in this, which we know is the nums array 1, 2, 3, 4, 5. We're starting as the return value, as the thing that's emitted. We're starting with an empty array, and each time around, each time we get one of the values from nums, 1, then 2, then 3, then 4, then 5, in X, we're sort of ignoring X at the moment. In fact, we could put X in there, right? Let's do that. Let's just run that whole thing. All we're doing is we're sort of starting to build up an array with the same values. So actually there's only a small step from there to say actually what we want to do, because we're doing a map, we want to apply the function that we're given to each of the items. There, let's just try that. Does that make sense? Does that make sense? So first of all, we've seen what this is in this function context. Secondly, one of the beautiful things about concat is it returns an appropriate value. It returns the new array that we can then, of course, use as the value of the accumulator next time around. That's the whole point of what comes out of this iterative function, is used as the accumulator for the next element. Okay, remember in episode 1 or episode 2, we came across a function. If we say here nums.push 99. Okay, if we run that, we get 6. Why do we get 6? Beautiful. Oh, yes, exactly. Open square brackets, close square brackets, an empty array is the starting value. Oh yeah, and also one of the things we've seen from this now is that we don't necessarily have to use reduce to reduce a list of things down to a scalar. We can create structures. Yeah, I mean, we could even, it's ridiculous, right? We could even say, add in, well, I mean, this is ridiculous, right? We could say, X like let's see what happens when we do that. There, we can build complex structures if we wanted to, but we don't want to. Let me run this thing again. REPL clear. This one, nums.push99. Let me know in the chat. We'll run it again and again and again. Let's evaluate nums. What is it? 1, 2, 3, 4, 5, 99, 99, 99, 99. Why are we getting 7, 8, 9 there? Another horrible thing is that push mutates the array that it's working on, which is a not a nice thing in functional programming. Okay, immutability, as in the non-changeability of data, is a super important thing. Otherwise, you're going to go crazy. But we'll talk about that another time. Okay. We've also seen then that reduce is an amazingly powerful and useful function for building other functions with, So you could write your own filter function with reduce. You get the idea, okay? Reduce is super powerful. It's almost like a little machine, a sort of fundamental machine in functional programming. Okay, so let me know, put in the chat why you think it's producing these weird sort of increasing numbers of increasing value. What's the word I'm looking for? Ascending values of numbers. I don't know. Anyway, and the point is that A, that's interesting, but B, it shows us that there are some functions in standard JavaScript that don't lend themselves too well to chaining. Okay, so there's a channel 4 link for you if ever there was. Let's talk about chaining while you tell me, or somebody tells me in the chat, what the 7, 8, 9 is. Okay, so by the way, chaining is the sort of the subject of this thing here. This blog post that I've shared a link to. Let me share the link again just in case. Shared a link to there. The function chains. Where is it? Where's an example? Where is it? Oh, there. Here's a super simple function chain. Okay, we're going to do something similar. So Kiara says, is it the, there's a heart in, yes, I don't know why YouTube chat puts like this emoji thing on the right hand side, because I can never see what the last bit of the sentence is. I think Kiara is saying, is it the length of the array? It is exactly the length of the array. Exactly. Well done. Thank you, Kiara. In fact, MDN array push. Yes, here we go. The push method of array instances adds the specified elements to the end of an array and returns the new length of the array. Brackets, unfortunately, rather than the array itself. But then again, I can sort of understand why it's not as important here, because it's making a mess of things anyway, because push is mutating the original array anyway. So, okay. So, let's play about and start our journey towards some sort of function chaining. Now, a lot of the, where is it actually? Tags, FP. Yeah, a lot of the stuff here, let me just put that in there as well. Functional programming resources, there we go. A lot of the stuff in there talks about chains of functions. Okay, so you can dig into there as well. Don't need that, don't need that, we've done that. Do we need that? Well, let's leave that anyway. Let's get some data. I was thinking about this morning as well. A little walk, and from the developer challenge last year, the North Breeze service, which is like a cut down version of North Wind that I created, is still running, which is quite cool. And we got products. Okay, I love North Wind. But the reason I call it North Breeze is because it's like a cut down version of North Wind. It's just got products. What has it got? Products, suppliers, categories, total product. It's got some other things as well, but those three things: product, suppliers, and categories. So we've got products. And products is nice because, you know, it's an understood data set. It's not huge. So let's, in fact, there are 77 products. Okay. So let's grab it. Do we need this anymore? So let's leave that in there. Let's leave that in there. Curl. What is it called? Products. Products to JSON. I think that's right, isn't it? Yes, there. Let's have a look. Products.json. There we go. Okay. Well, in fact, what am I doing? What am I doing? There. So we've got the context and we've got the value. So let's go back into, maybe we should start a new one. Chains.js. Okay. Why don't we say const products equals require products.json dot value. It was value, wasn't it? Well, let's just double check. Yes, there we go. Look, so products dot object dot keys products. We get, oh, that's right, the context and value. Okay, fine. And put my head at the top again. Oop, there. So while say const products equals dot value. Okay, products require products. So now we can say products.length. Hopefully that's a thing. 77. There we go. We got 77. Okay, fine. Products. There. So now let's start out really simple. Let's just say we want to see the names of the products. Products of the first product, like that, right? But we can say dot product name chai. Okay. If we want to see all the product names, of course, products.map. Oops. Now, what do we need? What do we think we need in here? Map is a higher order function. It iterates over the elements of a list. I'm using the word list generically, lowercase l, rather than use the word array, which is like the object type, as it were. It iterates over a list and applies the callback function that we give it to each of the elements as it is iterating over them. And the result of calling that function on the element value is the result of the value in the new array. Keyword new array. So it doesn't change the original array, it creates a new array list. So Visa says, because it returns the length of your array, yes, exactly. Thank you, Visa, and thank you, Kiara, exactly. That was about the push, by the way. If we were to say, well, let's do the simplest thing that could possibly work. And that, you know, it's ridiculous to say that, but you know, it's only because I think in here, Q macro there, K, I saw it there, right? I talk about that in this blog post. So let's do that first of all. What's he going to do? He's going to produce the list, which is an array, of course, and each element is an object. You know, there's one there. There's one element, which is an object. So we can now say, for example, x dot product name. Should we run that? Okay, so we just get. Andrew said, oh, yes, Andrew, thank you. That's perfect. Yes, x is the parameter, and what is returned from the evaluation of this function on the given element as they're being iterated over, is the attribute extra. So, for example, we could say here discontinued. There's another one there, right? So we run that, and we get a series of booleans. Now, that's interesting. Yes, I want to talk about booleans in the context of filter, in the context of a predicate function. Can anybody tell me in the chat what they understand a predicate function to be? What particular property does it have? Now. In fact, why don't we dig into that now? Oh, actually, no, let's just dig into what Andrew said. We could say, for example, const, to use Andrew's sort of attribute word there, attribute, that x can we try that? And then we can just say attribute discontinued attribute. Oh, sorry, discontinued. Undefined product. What are we doing here? X of oh, sorry. What we don't want. What do we want? Attribute. Oh yeah. Okay. So we want. Yes. Yes. Of course. We could say x return x of attribute. Okay. Like that. I'm just making this up now. But have I messed this up with? I won't use const, right? I'll do that. Assignment constant variable. Okay, let's just go out here. Let's go back in again. Let's get rid of the constants. Products is okay. REPL. And now we can say is discontinued. No, we could say name equals at product name, like that. And then we could say name. Name. What's name there? Name, we can't do name because name is deprecated. Let's say p name, right? There. Let's run the whole thing. Undefined is not a function. What? Products map p name. What is p name? What am I doing wrong here? Oh, of course. This takes. What am I doing here? What am I doing wrong? Takes an X. Oh, of course. And takes an attribute. There we go. A X A. Let's just try that. So attribute A. Yes, there we go. There we go. P name is that. So let's just try. Bear with me a second. My brain still needs to stop working. Let's do it on the whole thing. Yeah, there we go. Okay, so now let me just try this. Now, products map P name. There we go. Okay, so I confused the heck out of me for a second. I was just trying to be too lazy. Do you want me to be truthful? Always, Andrew. Andrew, always. Be truthful, Andrew. I wanted to just play around with this because this is also about sort of partial application and also function construction, which we're going to go on to later on. But it's also about closures. Okay, so I wanted to cover the closures from last time as well. But anyway, that was a stupid digression on my part. I apologize. So that is in response to your question about predicate. Ah, okay. Very good. Yes. Okay. So thank you for bringing me back on track, Andrew. So predicate functions. So Andrew is very, very erudite there, and very funny as well. So let me just, you know, if you get that, you get that. If you don't get that, I'll explain it another time, maybe, because that was crazy. So filter, in fact, MDN filter. The filter method of array instance is correct. Shall I copy the portion of the array filtered down to just the elements from the given array that pass the test implemented by the provided function. Has it got the word predicate in here? It hasn't got the word predicate. Okay, interesting. Anyway, so a predicate function is a function that returns a Boolean value. Okay, and filter needs a function, an iterator function that returns a Boolean value. So let's say, if we say, for example, products, let's run that. We can see that we got discontinued, right? So products.filter, let's just run one, right? X dot discontinued, if it's true. In fact, let's run that. 8, okay, and obviously then if they're not discontinued, we have 69. 69 plus 8 is 77. Perfect. Now, what's happened there? What's happened there is, in fact, let's do this, right? True. In fact, p name, right? Let's do that. We're already doing function chains without even thinking about it, okay? We did a length as well. If we run that, what do we get? We get all of the product names, because basically filter will return an array consisting of elements that quote unquote pass the test, elements that for which when the iterator function is called, for which the iterator function returns true. If I were to say false here and run that, we get an empty list, of course. So we can say, oh, there we go. Let's just have a look at products here. Products. Unit price. Okay, unit price. So we could say products filter x dot unit price less than 10. There we go. In fact, how many are there? Length. There are 11. Okay. So now already my brain is thinking, well, there's too much data over here, right? There's too much stuff to see. So I want to cut it down anyway. So in fact, let's start thinking about, first of all, sort of reorganizing the code. Invalid REPL keyword. What? Oh, interesting. Can we not do that in the REPL? It's just products. Okay. Products.filter. That's very interesting. Why can't I do that in the REPL? Evaluate the whole thing. Products. Let's evaluate that. Okay, fine. Products. Interesting. So we have to somehow, maybe do that. No, that can't be that, can it? No. Interesting. Okay, well let's do it on the same line, but let's have a space. This is also very, very Daniel Hutzel and Co. style. Let's evaluate that line there. 11. Okay, 11. Let's say instead, actually, I only want the names of those products that are cheap, less than 10. Okay, so map x.name, product name. Come on, DJ, type properly. There. So already we're seeing the value of thinking about processing a list of elements, an array, through this sort of pipeline of functions. Let's say we were to say, for example, is discontinued equals x dot discontinued. Now, that sounds a bit stupid, doesn't it? However, there are two things to note here. I've just defined a function, a super helper function. The function, what type of function is it? It's a predicate function. Okay. I mean, implicitly, it's a predicate function. Explicitly, the values for discontinued are Boolean. However, there's a concept of a truthy and a falsy value, as in, undefined is sort of false, whereas a value that is like, 1 or 42 or 99 or banana, those are sort of truthy values. But anyway, we're dealing with a Boolean value here in the discontinued property, so let's go with that. So let's say we just wanted to find the discontinued products. Discontinued. Those are the discontinued products. Notice also how, by convention, the name of predicate functions starts with is. Okay, that's just my convention. It's other people's convention as well, but it makes a lot of sense. But also, look at this again. I use this phrase, and Andrew picked up on it in episode 1, I think. This is sort of solid state code. It doesn't move. There are no moving parts there. The surface area is also reduced, and there's less to go wrong. There's less to have to debug, and so on. There's no sort of state. There's no sort of iteration variables for I equals 1 to 10 or whatever, right? And then we could say map. Well, let's just have the product name for now. P name, because we've still got P name here. Let's run that and then run that. There. Okay. So those are the ones that have discontinued. But what if we wanted to figure out how many units of stock we had of discontinued products in total? What we could say is map, go and get the units in stock. Okay, let's move that over here. Let's do that first of all, right? 0.29, and then of course we go back to our old friend. In fact, let's bring in this add again. Add equals x, y, x plus y. Oh, we need to add first of all. There. 101. So we can very quickly and easily build up chains of functions: filter, map, reduce. And imagine this is purely this sort of REPL thing here, because I think in a normal REPL, Node.js REPL, we could say 1, 2, 3. Oh, maybe it's because maybe I can't do that. So if I say, editor, I was thinking of this 1, 2, 3 dot length. Yeah, okay. I wonder if there's a possibility of doing that in here. Anyway, ignore that for now. But you can imagine there. You can imagine constructing chains of functions through which data flows. Okay, and also notice that at the end of the day, we could say here, product, we'll do that. Oh, let's put it back on here again because it will execute it. Notice as well, oh, I can do this, can't I? The word v word there. products is unchanged. So none of these functions here, filter, map, or reduce, have modified the original products value. Okay, products is still this array of 77 objects with multiple properties. Anyway, I just realised it's 9 o'clock. I hope that was okay. A little bit random, but there we go. So next Friday we'll just do a little bit more function chaining and then start to move back to this whole idea of partial application and dig in a little bit more to what we saw in the Ramda REPL, and then start to move towards thinking about point-free coding, and then also maybe lay the path for composability. Okay, have a great Friday, have a great weekend, and I'll see you next Friday. Bye for now.